In this question here, we are required to prove that the sum that we're given here is a convergent geometric series. So the first thing we're going to do is we're going to establish the series by starting at k is equals to 1. So it's going to be k is equals to 1, and then we're going to substitute it in this formula here, which is 4 multiplied by 3 to the power of 2 minus, where there's k, we're going to put 1. It's equals to, so punch your calculator, you're going to get 12. So that's the first term of the series. The second term of the series is k is equal to 2. Oh, at k is equal to 2, sorry. So it's going to be 4 multiplied by 3 to the power of 2 minus, and then we put 2 where there's k. Then the second term is going to be 4 if you punch your calculator. And then k is equals to 3. So it's 4 multiplied by 3 to the power of 2 minus 3. And then you punch your calculator, you're going to get 4 over 3. So these are the terms of the series. So it's 12 plus 4 plus 4 over 3. So remembering that we are told that this is a geometric series. So to prove that it's convergent, we have to first find the constant ratio, which is r is equals to t2 over t1. It's equals to t3 over t2. So t1 is this one here, t2 is this one here, and t3 is this one here. So t2 is 4 divided by t1, which is 12, equals to t3, which is 4 over 3, divided by t2, which is 4. Then if you punch your calculator, you're going to get r, which is equals to 1 over 3. So 1 over 3 lies between minus 1 and 1. So if it lies between minus 1 and 1, therefore it confirms that this series here is convergent. So therefore the series is convergent. So in this question here, 3.2, we are given this sum here, which is equals to 2 over 9. So this is the sum to infinity, as you can see on top here. So it's equal to 2 over 9. So we're required to determine the value of p. So the first thing we're going to do here is, since we know that this is the sum to infinity, we're going to say the sum to infinity is given by a over 1 minus r. But we need to first identify the value of a, right? Because the value of a, we already know it. What is the value of r? Sorry. The value of r is given by 1 over 3, which is what we calculated in the previous question. And the sum to infinity is equals to 2 over 9, right? So we need to identify the value of a for us to be able to work around finding the value of p. So the first thing we're going to do is we're going to identify the value of a. So the value of a is found by first saying establishing k is equals to p, which in this case we're going to say is our first term. Then we're going to substitute the p in the formula. So it's going to be 4 multiplied by 3 to the power of 2 minus p. So this is going to be our value of a. So in our formula of sum to infinity is equals to a over 1 minus r. So the sum to infinity is 2 over 9, which is equals to our a, which is 4 multiplied by 3 to the power of 2 minus p, which is what we calculated here, divide by 1 minus r, which is 1 over 3. Then we're gonna add everything up. So it's gonna be 2 over 9 is equals to 4 multiplied by 3 to the power of 2. So we're going to break this down using the laws of exponents. So it's going to be 3 to the power of 2 multiplied by 3 to the power of minus p. Multiplied by 3 to the power of minus p divided by, so you're going to add this using your calculator. You're going to find 2 over 3. Then we're going to cross multiply here. So it's going to be 2 over 9 multiplied by 2 over 3 is equals to 4 multiplied by 3 to the power of 2 multiplied by 3 to the power of minus p. So if you multiply these two here, and these two here, you're gonna get 4 over 27, which is equals to 4 multiplied by 3 to the power of 2 multiplied by 3 to the power of minus p. Then let's divide by 4. So you're going to divide by 4 and you're going to divide by 4 here. So you're going to have 4 over 27 divided by 4 is equals to 3 to the power of 2 multiplied by 3 to the power of minus p. So it's going to have 4 over 27 times 1 over 4. So because it's division, when you change the sign to multiplication, it's going to tip and multiply. So you're going to have this 4 here going away with this one. So it's going to be equals to 3 to the power of 2 multiplied by 3 to the power of minus p. Then what we will have here is it's going to be 1 over 27, which is equals to 3 to the power of 2 multiplied by 3 to the power of minus p. But we know that 27 is the same as 3 to the power of 3. So we're going to write 1 over 3 to the power of 3 is equals to 3 to the power of 2 multiplied by 3 to the power of minus p. And then we're going to divide by 3 to the power of 2, divide by 3 to the power of 2, which we have 1 over 3 to the power of 3 divided by 3 to the power of 2 is equals to 3 to the power of minus p. Right? Then you're going to have 1 over 3 to the power of 3 times 1 over 3 to the power of 2 is equals to 3 to the power of minus p. Right? So let me just rub this one here. So now what we have here is 1 over 3 to the power of 2 multiplied by 3 to the power of 3 equals to 3 to the power of minus p. So you're going to add these two here because the same base you add the exponent. So it's going to be 1 over 3 to the power of 5 is equals to 3 to the power of minus p. Right? So then what you're going to have here is, let's take this 3 to the power of 5 upwards. So you're going to have 3 to the power of minus 5, which is equals to 3 to the power of minus p. So if you're having same bases like these ones, which are equal by this equal sign here, you're going to drop the exponents. So the exponent of these 3 here, it's minus 5, equals to the exponent of this 3 here, it's minus p. So minus p is equals to minus 5. So you divide the negative, it goes out, so which means that p is equals to 5. So this is the answer to this question here.